So as soon as it says tangent line, so tangent line means we're going to need to, get to, find the derivative. For the equation of a line, you need the slope. That's what the derivative is going to tell us. You also need a point. Right now we only have x, so we also need to find y. So y equals, plug in a 2 squared sine of 2. Notice that this little x does not have a little degree symbol on it. That means this is in radians. So make sure that your calculator is in radians, and then find 4 sine of 2. So the y value is 3.637. That's sort of a cool number, 3637. So the point is 2, 3.637. All right, now set that aside and work on the derivative. This is a product, so you need to use the product rule. So it's going to be the derivative of the first one, and then the second one left alone, plus the first one left alone, and the derivative of the second function. So y prime will equal the derivative of x squared. That is a 2x. And then just copy down the sine function, plus leave the x squared alone, and the derivative of sine is cosine. There's the derivative. Now plug in a 2. So y prime, when we plug in a 2, will be 2 times 2, then times sine of 2, plus 2 squared, and times cosine of 2. So there's a 4 times sine of 2 plus a 4 times cosine of 2. It's 1973 with a decimal. And that is the slope of the tangent line. Now to find the equation of the line, just do the point slope formula. So y minus the y value 3.637 equals the slope 1.973 times x minus the x value of 2. And then I should just simplify this one. So go ahead and distribute this 1.973. So 1.973x minus, if I just say times 2, then it'll take that last answer and plug it in right there. So that is a 3.945. But of course this had a minus, so that's a minus. And then the last step would be to solve for y, just add 3.637 to both sides. Which is a negative. Hold on, let me write down this part first. Which leaves behind a negative 0.308. Now I'm going to graph the original function and make sure that I got this right. So y equals, the original function is x squared times sine of x. And for the window, it needs to be close to where x is 2. So if I go from 0 to 4, that should be good enough. And I don't think the function is going to be very tall. Maybe if I go from -5 to 5, I'm guessing on the y values. Oh, what a good call. Good job, Greg. Thanks, Greg. So if you trace and plug in a 2, we're talking about that point right there. So the tangent line should go like this and just hit the function right there at that flashing cursor. So let's see if we've got it right. 1.973x minus a 0.308. And then graph, and at that point 2 looks perfect. Now another important thing that we're going to be using the derivative for is if you zoom in on that point. Okay, here we go. Zoom in on that point. You'll notice that in this area, the function, so on this area, the function and the line are very close to each other. So that means at least in this area, you could use the line to estimate the function.